You'll learn that there's many amazing things you can do with completing the square, which is today's topic, but today we're just going to focus on how we do it. Completing the square is a clever way to get the x squared and the x term of a quadratic into a bracket. We have shown these terms graphically here. Let's chop the x term in half and try and make a square. You can see we almost have succeeded. Ignoring the top right gap, the equation of our square is x plus b over 2 squared. The gap has the equation of b over 2 squared. X squared plus bx can therefore be written as x plus b over 2 squared minus b over 2 squared. Let's go through these questions. We start by focusing on the coefficient of the b. We'll be adding half of it inside the bracket with the x and subtracting the square of half of it. So all we need to do is substitute the b into this formula. So b is 10, so it would be x plus half of 10 squared minus half of 10 squared. So it would be x plus 5 squared minus the 5 squared. So x plus 5 squared and 5 squared is 25, so it would be minus 25. And that means we have now completed the square. There are a couple of changes in this question that make it a bit trickier. First, we have a coefficient of the x squared term that isn't 1. Also, we have a number term. Completing the square only works when a, as in the coefficient of the x squared term, is 1. We'll need to factorise the 2 from the x squared and the x terms. We can now complete the square for the terms inside the bracket. So our b is minus 7, so we're going to do a bracket with x minus half of that, 7 over 2, squared, minus, and then we're going to have that minus 7 over 2 squared. It's sometimes easier to work with decimals, so I'm just going to convert those into decimals. And then what we need to do is expand the bracket. So we're going to times both the x minus 3.5 squared and the minus 12.25 by 2. And we can add the number terms. So we've got minus 24.5 plus 9 gives us minus 15.5. In this question, we're asked to solve by completing the square, and we've got an equals 0 there. So instead of having to factorise that 5 out, we can just divide all the terms in the equation by 5 to get that coefficient of the x squared term as 1. And then we just need to complete the square. So our b term is minus 4, so half of that will be 2. So it would be x minus 2 brackets squared minus 4, which is 2 squared. And then we've got that minus 28 over 5 at the end. Now we can collect the number terms together to get 48 over 5. And next we can add that to both sides because we are asked to solve. And you can see here we've got a squared that we need to get rid of. So we're going to square root both sides. So we've got x minus 2 equals plus minus the square root of 48 over 5. Now, I know that 48 over 5, using our surd knowledge, we can rationalise the denominator. That's the same as root 48 over root 5. Rationalise the denominator and simplify, and it can give us 2, because we've added the 2 to both sides, plus minus 4 root 15 over 5. And we know when there's a plus minus, there's a plus version and a minus version. And we can leave our answer as a surd. Let's finish up on this thought. What do you think you would get if you completed the square for ax squared plus bx plus c? Give it a go yourself. You might need a bit of help from a teacher, but you will be interested to see what you get. And if you manage to do it, let me know in the comments below. And also come to onmaths.com or click the link in the description where you can access all our A-level papers and predictions for free, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.